Hello and welcome to Talking Points. I'm Dave Kelly, Director of Advanced Media Production at Cal State Long Beach. Today we're going to talk about one of Earth's most precious natural resources, the ocean habitat. My guest today is Michael Schaadt. Mr. Schaadt is the Director Emeritus of the Cabrillo Marine Aquarium in San Pedro. Welcome, Mike, and thank you for joining us on Talking Points.
Thanks a lot for having me, Dave. This is a great opportunity.
Well, when we talk about the ocean, obviously we're talking about a whole lot of water. And just to put this into some perspective, we know that about 70% of the Earth's surface is covered by the ocean. We also know that that amounts to, in terms of gallons of water, about 326 million trillion gallons. And if people are into numbers, it looks like this, 326 followed by about 18 zeros. So that's a lot of gallons of water. In terms of depth, we know that the ocean varies in depth. At its deepest point is the Mariana Trench, which is about 6.8 miles. But the average depth is maybe around 2 miles deep, but it does vary. So what does all this water mean for the environment and for our survival as humans?
Well, basically what it means is that there's an awful lot of places for organisms to live. And that's something that I'd like people to think about for a minute is if it's the average of 2 miles deep and it's 70% of the planet, that's a lot of living space, especially when you think of the land area that we spend most of our time looking at and living in. Mm-hmm. There's a lot of animals and plants living throughout that entire depth, from the bottom all the way to the surface and in the middle.
And we also know that the ocean is salt water. It's very salty. It's, as a scientist, you're going to tell me it's 35 parts per thousand salt, but the composition to us lay people is about 3.5% of the weight of the ocean is salt. Where does all that salt come from?
You know, there's every indication that over eons and eons as water has struck the planet, as the planet has changed, that salt has leached out through the rivers and eventually into these basins that became the oceans. So that's basically where it came from over a very, very long period of time. Geologic time is how the ocean has become salty.
So there's a bit of runoff that comes from the land?
Constant runoff, and to this day it continues.
And what about underneath? Is there anything underneath at the bottom of the ocean that percolates up in terms of salt?
I think what's really interesting about that, maybe not so much from the salt point of view, although that's part of it, is all the other minerals that are being bubbled up from a very active planet's core in the case of the Earth. So it's coming up through these hydrothermal vents, which, by the way, biologically is very interesting and fairly new to science within the last 50 or so years.
All right, we also hear a lot about icebergs, particularly in the Arctic Circle, that are melting. And we obviously have a lot of ice in Antarctica as well, in the southern hemisphere. But when icebergs are melting, or when ice is melting in the Arctic Circle, how will that affect the oceans in general, and how will it affect the coastlines?
So that's basically fresh water, and as that fresh water is added to the system of the ocean itself, certainly some of that salinity is affected. But more importantly, from our standpoint, from people living near the coast, for instance, is that it is causing the sea level on the average globally to rise. Now, that's not only because of the addition of this more water that was sequestered in these big glaciers that are kind of connected to land. It's also that the ocean water globally is changing by climate change and affecting the heat capacity of the ocean, making it warmer. And warmer water takes up more space than colder water. So that's also part of why we have a sea level rise that we're going to be experiencing for the next, as near as we can tell, quite some time on the Earth's future.
And we'll have a chance to talk a little bit more about the climate change and global warming and that sort of thing later. But I want to now talk about the human involvement in the aquatic environment, and particularly what the human population growth means for interaction with the ocean habitat. Now, just to throw out some numbers about population, we know that in 1927, which is about 90 plus years ago, the population on Earth was at 2 billion people. That was the estimated population. Today, we're looking at 7.5 billion people on the planet. So in just a span of 90 years or so, we've added 5.5 billion people to the planet. Now, how will all of those extra people have an impact on the ocean that they may not have had when we only had 2 billion people on the planet?
So, you know, people eat, and people have waste, and people also do things. And all the things that I've just very simply said has caused, for instance, in the case of the Industrial Revolution, where we're taking fossil fuels and we're burning them, it's causing carbon dioxide to build up in our atmosphere, which is causing a warming area. In the case of eating, there's only so much protein that people can get. In the case of the ocean, for instance, taking fish from the ocean, which is where that protein is coming from, there's a limit to how much fish that can be available. And we have shown in the last 100 years that we have the capacity to be very good at collecting fish for our eating and all the things we want to do with fish. So much so that the populations have not been able to replenish from our take. And that is what I refer to as a sustainability issue, a sustainability problem. How do we sustain those populations in the ocean so that we can take some and still have them replenish themselves?
And so what you're basically talking about is overfishing. We're at the point now where we're engaging in overfishing. And so what are the causes of the overfishing, and why are we overfishing? Is it necessary, or is it not necessary to overfish?
Well, it isn't necessary to overfish. However, most of our history has resulted in not understanding that we could even overfish. Now it's painfully obvious to us that we can do that, because species after species of fish that we used to be able to get in very large numbers is now not available, or available at very low numbers. So we've proven that we can overdo our fishing, we can overfish. Mm-hmm. What we have to find ways is to manage the populations so that they have the ability to replenish themselves. And in many respects, take on some of the land-based farming activities that we have proven, and that has been going on much longer worldwide, that we can apply to farming the ocean, aquaculture.
Mm-hmm. We'll talk about aquaculture in a moment, but I want to get to sort of the political and social and economic issues involved with how we fish or overfish the ocean habitat. It might be easy for us sitting here in the United States, which is a relatively well-off country, one of the most well-off countries in the world, to say, all you other guys need to stop fishing. It's causing a problem. But some of those other countries that are doing this are much less well-off economically. Culturally and socially, fish has been part of their diet for many, many years. There are a lot of people who make a living off of fishing, and that's their sustenance. And to say that this is unsustainable doesn't make sense to them necessarily, because that's what has sustained them for so many years. Can we find an accommodation? Can we reach some level of understanding so that we have limits, yet we don't impose on other people's cultures and lifestyles?
I think most successful issues regarding overfishing have not gone in and told somebody, you're doing it all wrong, quit doing it. Those have not been so successful. What has been successful is when you go in and you show them what's happening and you have them be part of making the solutions, whatever those solutions happen to be. And in some cases, it's not one solution fits all scenarios. It could very well be that in some places, changing the season at which they take the fish that they're after starts making a difference for sustainability. It could be that their fishing techniques, changing that, help sustainability. It could be switching to another species, allowing the first species to recover is one of the ways. So there's many different ways to go about it. But certainly we've learned that most successful ones are when you have everyone working together so that there's a solution that's found.
So education is obviously key in terms of knowing about the habitats and the seasonal applications and all of the other permutations that we're going to go into having these understandings with our growing population.
Like so many other things in today's world, it is education. And also along with that education is a matter of trust. Because I think when you educate people and help them see what these issues are, that the trust comes along with it. And then people start working together for a solution.
Well, let's talk about one of the solutions to overfishing, and that is having what's called fish farming. And we see this with salmon in particular, salmon farming, where we're actually growing large numbers of salmon in controlled areas. What is the problem? It sounds like a good solution, actually, but what is the problem if you have, let's say, 500,000 salmon growing in a netted perimeter of about 4 football fields in terms of size? What are some of those problems?
Well, you know, I think it's obvious to people when they start thinking about it, especially the way that you just described it, Dave, and that is that you have these fish very close together. That is an unnatural way for them to live. And that means that they're very close to each other so that if one of them gets sick or gets a parasite, it is passed along very well. I always have people think about having people live much closer together. Diseases are passed on much easier. Also, there's a big issue dealing with the waste products of all those people, and in this case, all those fish being in the same place. In the old days, those waste product problems used to be taken care of by moving the big net that you described from an area that is kind of polluted underneath it, because remember, everything falls through the net and goes to the floor below it, the seafloor below it. They just move it over. Well, that area is now not usable, and it becomes a problem for the natural environment to replenish that. It takes a long time without people intervening to take some of those places with all that excess food and excess waste that's down below. So you do have these issues with parasites. You have these issues with diseases. You also, in the case of salmon, they feed on other fish. So now you're having to go out and collect fish from the sea and feed it to these other fish. Well, you're going to need a lot more because you have a lot more fish to feed all those bigger fish. So now you're essentially affecting the environment by taking away that food fish from the natural environment. So there's a lot of issues that come up when you start talking about fish farming.
We have just about a minute before the break, so before we get to the break, let's talk about shrimp farming and shellfish farming as well. Similar concerns?
Very much so in the case of shrimp, and people may know this already, but shrimp is the most sought after and the most eaten seafood in this country, the United States, by a long shot, by the way. And yet, they also have to feed on organic matter, on protein, on whatever we're feeding them. They also have waste products. Quite often in the case of shrimp, they have these, at least historically, these fish farms right on the coast, which means that the fish farms are taking up, in most cases, an area that would be used as a natural wetland. And these natural wetlands are kind of filtration, natural filtration from the land to the sea. So by having these areas for fish farms, or for shrimp farms, we're essentially changing that particular environment and maybe not bringing it back to its original environment at all.
Okay, and on that note, we'll have to go to the break. And when we come back from the break, we'll talk about sharks and shark finning and shark fin soup. And we'll also talk about the impact of the Fukushima nuclear disaster on the Pacific Ocean. Stay tuned.
Ever thought about studying the psychological ecology of sharks using robots? Or maybe spending the day not in a classroom, but aboard a large vessel, studying marine life in the ocean, firsthand? The opportunities are endless with a degree from Cal State Long Beach.
Welcome back to Talking Points. I'm Dave Kelly. My guest today is Mike Schaadt. Mike is the Director Emeritus of the Cabrillo Marine Aquarium in San Pedro. Mike, before we went to the break, we were talking about salmon farming and also shrimp farming. I think it's important to point out that there are farm-raised salmon and shrimp that are perfectly acceptable as food items for our kitchen table. There's a site that's put out by the Monterey Bay Aquarium, and it's called www.seafoodwatch.org. What does that site tell us, and why is that a good site to check in terms of when buying those groceries?
You know, this is great to talk about because most people that look at what protein we need from the ocean in the future, aquaculture is a big part of that. So we don't want, at least I don't want people to just throw out the idea of aquaculture is not the thing to do. What I do care about, and people that I work with, is that we choose aquaculture that is sustainable. And that's really what Seafood Watch at the Monterey Bay Aquarium is doing, is they are finding out which one of these farms, for instance, are meeting the criteria such that they're not putting too much more of an impact on the environment they're growing them at, that the way that they do it is not only sustainable from the organism point of view and the habitat point of view, but even through such things as hiring people. So all of these things need to be taken into account, and Seafood Watch is doing that kind of work so that we can make good choices. And I think what it's going to do is cause more aquaculture situations to be sustainable in the future.
And that's all good news, and that's all progress.
And something we should be supporting.
Absolutely. So let's talk about sharks. And according to the Smithsonian Museum of Natural History, humans are killing about 100 million sharks every year. And one of the concerns is shark fin soup, which is a cultural favorite in Asia. And shark fin soup involves cutting the fin off of the shark and using it for the soup. What's wrong with that, and what's the problem with that?
Well, I think the basic thing that's wrong with it is it's not sustainable. So by taking 100 million sharks, sharks are slow-growing organisms in general. They have fewer babies in general, takes them longer to replenish their populations, and taking out 100 million at a time is going to, and already has, made a big difference on worldwide shark populations. So that's the first thing. But the other thing is that as these fish, these sharks are taken and the fin is cut off, the fishermen don't have as high a price for the rest of the body. So what they do is they just dump the carcass over the side. Now what that does is it kind of wastes that protein. It goes down to the bottom and slowly decomposes. So the point is that there's better ways to go about that, but the key thing is that if we're going to allow people to take sharks, either using their whole bodies or using their shark fins, then they should be taking them in a sustainable fashion.
Now, this is a favorite dish in China. However, the Chinese government, to their credit, has recognized that shark finning as a practice, as you've described it, is not sustainable. And so the government of China has banned shark fin soup for official government banquets as of 2012. However, that's for official government banquets. The privately run hotels in Beijing and other cities in China, only about 6% of the luxury hotels are actually not serving shark fin soup. So it remains a cultural favorite. How do we address that from, again, a cultural standpoint and being sensitive to the culture and making it a more sustainable practice?
I think the key, as most things in life, is education. Is making sure that people that are eating this understand the worries people have and what's happening, including them in this data gathering so that they can see that it's not going to be sustainable. That even if they wanted to continue it and the populations are going to dip to the point where it's not, they're going to be taken out away from their choices in that regard. I think that's where things need to happen, is educating people of why taking all these sharks out of the system is a problem. And it's not just the populations of sharks. Sharks play a role within an ecosystem, and we're going to start seeing a lot of other populations of organisms change accordingly.
You know, interestingly, the converse of that is here in Southern California, where we're actually seeing an uptick in the number of sharks that seem to be visiting our coast. And that's actually a good thing, because it means the population of the food supply that they prey upon is growing, which means we're doing a better job of managing our habitat here than we did maybe 50 years ago. So what about that increase in shark travels along the California coast?
Well, you know, there's active research in that right now, but I think most researchers agree that taking the gill nets that were used to be allowed close to shore and forcing them farther offshore has made an impact on some of the sharks, especially the white sharks. Now, when you say that we're getting an uptick of sharks, most people are applying that to the white shark population. And indeed, there are more of them out there. And we have Dr. Chris Lowe that has done a lot of work in the Shark Lab at Long Beach State that has made a huge difference in understanding just what's going on, and it's going to make a huge difference in the future as they continue to study these sharks. But the bottom line is that as the population continues, as you say, they do have their primary food item available, not only for the babies, the bottom-dwelling fish, but also the seals and sea lions that have increased their numbers, especially sea lions, to the carrying capacity for their environment.
All right, let's go back to the other side of the Pacific, to the, I guess we would call that the Western Pacific, since we're in the Eastern Pacific here on the west coast of the United States. Fukushima. We had that terrible earthquake and then the tsunami that followed immediately that caused the nuclear disaster at the Fukushima nuclear plant. We were really concerned. This was back in 2011, so it's been, about 7 years now. We were concerned that there would be a lot of radioactive elements coming across the Pacific over to our part of the world. But in the tests they've done on the kelp forest here in the West, it hasn't really shown an uptick in that way. So why have we been spared anything that happened from the massive leak of radiation from Fukushima?
Well, it really is a vast area that these isotopes would have to travel. And they did travel in the aerosol, in the airways. That traveled right away, and people all over the world were studying that. Especially physicists that were able to detect the signatures of those particular isotopes. They're able to do that and find out. So that initial fallout was the really big worry. And then people started worrying about the longer term isotopic isotopes making their way over to our coast. And that has not been the case so far, although we continue to study it. It appears that it fell out along with whatever it glommed onto, whether it's biological or something that was pieces of trash that would end up on the bottom. And there is some guess that there is still some of that isotope there. But you're right, the kelp forest was used here because one of the isotopes is taken up naturally by these kelp forests. And although it's been studied, there's more of these isotopes that come from our sanitary sewer system from people using radioisotopes in medicine than we're not finding it from Fukushima.
Is it safe to say that we're out of the woods in terms of the fallout that has come from Fukushima now that it's 7 years after the fact?
I think most experts would agree that's the case, but it's always a good thing to continue to study to see if there's some system or some method that we haven't understood so far. But we have continued to study it. And I know that the scientists that are doing the actual work so far have not reported that we should start worrying and stop eating fish or stop or somehow worrying about our kelp forests.
Let's talk about another concern that people have talked about. There is this story that's out there, and I'm going to ask you whether this is more mythology than truth, but there's a story that there's this big glob or blob of plastic as far as the eye can see when you're there, floating out in the ocean somewhere. And this is an indication of how much trash and garbage we have in the ocean. So 2 questions. One, is there really a big blob of plastic that one can actually see? Or the second question is, no actual big cloud of plastic, if you will, but there is obvious evidence of plastic contaminating the ocean environment.
Yeah, I think the reality is that, of course, you will see plastic in what they refer to as the Great Pacific Garbage Patch. That's really the term that we've been using. Scientists have coined, and now it's been used. But it's not something where you can walk across it. I think that's that is a misconception some people have. Obviously, it is, as you go across the North Pacific Ocean, you will find plastic regularly in the ocean environment itself. If you were to drag a net, you would find a lot of plastic. And it continues to grow. Yes, that's all true. And it's also just as worrisome as people imagine, because that plastic is not going to go anywhere. And what it does is, if it's broken into smaller pieces, which basically is one of the byproducts of long-term of plastic in the ocean, it's eaten by some of the organisms that are in the ocean. It not only takes the place of real food, that they're not obviously metabolizing plastic, it's just taking up, making their guts empty. It's also, the plastic itself will adhere harmful chemicals on the outside of it and disrupting some of the metabolism and causing animals to suffer in that regard too. So that's really where the worry is this plastic continues, and it will be there for decades. That's another thing we worry about, and just continues to grow. It's not getting any less.
We talked earlier in the program about climate change and the oceans becoming warmer and sea levels rising. I want to come back to that for just a moment. We know that one of the problems with too much carbon in the atmosphere from fossil fuels is that carbon eventually comes and sinks down into the ocean. It affects the plankton. The plankton absorbs some of that. It's called carbon sequestration in the plankton. Why is that causing problems, and why is the sea becoming more acidified?
So carbon in the form of carbon dioxide, which is one of the byproducts of burning fossil fuels, is not only causing this heat trapping blanket to the outside of our planet, but it's also causing at the interface between the air and the ocean surface, where there's constant movement of that carbon in the form of carbon dioxide. It causes a carbonic acid, it causes an acid forming, so slowly but surely the acidity of the ocean is becoming lower, it's becoming more acidic. Likewise, the organisms that live in that environment are also having to deal with normally, they're designed, they're evolved to the point of using and having ocean water at a certain acidity around their bodies to be able to make their shells and to be able to do the things they need to do to live. And by changing that acidity, it's going to change that capacity for them to do that. Finally, what it does is by making that heat trapping blanket, it's warming the ocean temperature. It's not warming it so that you and I, Dave, could go out today and then go out tomorrow and find a difference. But it is where we go out today and then our grandchildren go out when they're adults our age and they can tell the difference. Those are the kind of changes that are going to make a difference. And indeed, that's where we're headed.
We only have about 30 seconds left. The show really goes fast once we get into the conversation. But I want to just get one last point in, and that is, I think, don't we need to celebrate some of the successes, some of the success stories we've had in helping to restore the natural marine habitat? Because we have had that here in Southern California. We talked about the gillnet ban that we've had for a number of decades now. It's helped to bring back the fish population. We know that our harbor is much greener and much cleaner than it was 50 years ago. So do we need to celebrate those successes and make that clear?
We absolutely do, Dave, and there's easy ones. The Clean Water Act, the Clean Air Act in the early 70s, the Endangered Species Act, the Marine Mammal Protection Act, all of these things have made a difference. Recently, we can point to the Marine Life Protection Act, which has resulted in these marine protected areas off our coast, that's going to start and has already started within the last 10 years, making a difference in some of the populations off our coast. We do indeed have successes. And the point that I like to make to people, and I'll do it again today, if you feel as though nothing we've done has ever made a difference, why keep trying? The point is, we have made a difference because we've tried, and we need to try more in the future to make a difference.
And on that note, we have to close. That's a good note to close upon, but I want to thank you for being here and sharing information on this important topic.
Again, Dave, thank you so much for having me today.
And thank you for joining us for this edition of Talking Points. Please join us again soon for the next episode. Until then, I'm Dave Kelly. Have a nice day.